Hello, everyone. So, in a first, this time you're seeing this father-son duo on this podcast together. We have been each doing
Hello.
our own thing for the last 1 year on this channel, and are really happy with where we are with the content that we've been putting on. We have now got slightly over 2,100 subscribers, and hopefully by the end of this year we'll reach 10,000. But to do that, we're not really going to do any sensationalism. We'll focus mainly on information, insights, and even if the analysis is painstaking, we'll stick to this. Uh, we both come from a industrial automation and technology background and see industrialization as one of the core enablers for India to get to the $10 trillion economy mark or even realize the 2047 goals. So that's what we are fully invested in. Um, Now, the topic that we are going to cover today has been covered by people who are way more qualified than us. But it is a topic that is so close to our hearts as not just as engineers, but also as Indians, that we feel compelled to talk about it and to present our take on it and learn from it. So, we are, of course, talking about Operation Sindhur. Now, we we have a, a short slide deck that we want to take you through, and we'll share our insights as we go. So let me put that up. Is that visible?
Yes, it is visible.
Awesome. So this is an operation that has made us proud as engineers, as Indians, and I really cannot resist from talking about it. Do not want to make a fool of ourselves by going into things that we really don't understand as much. But we'll draw some parables. We'll learn some lessons from this operation, and also share some insights as engineers. What could be a way forward? Because like my father has already said quite a few times, that innovation often comes from other domains. But since he's the one who always purports this, maybe I'll let him share some insights on how innovations can, from one domain, can be used in another.
To answer your statement, to elaborate it further, see, innovation is about applying the fundamentals or observations from some other domain into a totally different domain for the first time. Okay. Now, talking of war more than war of arms or hand-to-hand fight. Nowadays, war is war of wits more than anything.
Hmm.
Who deceives whom? Who brings a surprise impact to the opponent? Okay. Now, if you see, there is a parallel in medical world. Okay, the pharma industry has been working overtime to develop newer and newer medicines. Why? Because the older medicines tend to become less effective, less and less effective. Once the bacteria and germs get used to those antibiotics, they are no longer effective. So every time you have to keep inventing some new medicine so that it has a surprise element for those germs and bacteria. Yeah. So something like that applies in warlike situation also, and it has been seen in Operation Sindhur as well. The main thing which struck everybody is the surprise element. Okay, it has taken everybody by a surprise. Nobody was expecting something like this could happen. Okay, and suddenly out of the blues, we pulled through something that was unexpected of us. Not only unexpected of us, unexpected of anybody in the world. Okay, the kind of integration, the kind of flexibility, the kind of agility, the kind of deception, the kind of crippling the opponent. Okay, all these put together, uh, I can compare it with the medical world. So it is
Hmm.
straight away an innovation, qualifies to be an innovation, literally. So, and going further, the idea of this presentation is also what other domains can learn from this Operation Sindhu. We are not here talking so much about the specs of the arms, those were used, etc. So many people have talked, so many people who are more qualified than us, who have first-hand experience. I mean, those are the people who should be talking about it. But we are talking what we have observed to be unique in Operation Sindhu. Okay, if you compare with, let us say, 2019, the surgical attack, as compared to that, what newer things you have seen this time? Okay, as compared to, let us say, couple of decades back, what newer things we are seeing now? Okay, and so on. So we'll be focusing more on uh, qualitatively what new things we see in this warfare. Okay, we are not going into specifics, we are not going into specifications. That's not our domain, and that's not our interest either. Okay, so that is something which we do not know, so it's better not to talk about it. But what we are talking is what newer concepts we have seen in this one, and what could be learned from those new concepts in other domains.
So, to add to that, so we are, of course, not from the defense background, but we've worked with some ancillaries, so we're not totally alien to it as well. But we do follow some developments in this space closely, and largely the reason behind that is a lot of these technologies from the defense domain, they find their applications in the civilian domain as well. So maybe if you can give an example or so of how something from a completely defense tech domain has eventually found its way into a civilian application.
I don't know if it has found way from defense or it is just incidental, but we have learned a lot about the aiming and tracking of projectiles that was utilized in this Operation
Hmm.
Sindhur, obviously. Now, aiming and tracking of flying projectiles. Okay. Now, I can draw a parallel that today, if you see a cricket match broadcast, you can see that all the time the camera is showing ball exactly in the middle of the screen. Okay, so obviously there is some software, there is some hardware which is tracking the ball as the ball is flying. Manually you could not do it so perfectly. Okay, now this is one technology which is somewhat parallel. Now here you are following a flying projectile which is a cricket ball. There you are doing so. This kind of cross learning can happen, and of course whatever concepts are used in defense can find way in some other sectors, certainly. And sports is
Yeah,
one such example we have seen already. Yeah.
I think there's another very famous example, and that is of the magnetron in the microwave, right? So I think Percy Spencer in 1945, he was testing this new vacuum tube called the magnetron, and he observed that the chocolate in his pocket was melting, and that's how. And this was a radar project for a defense company. So that's how microwave came to be uh, discovered, and then that eventually it found its way into our daily lives as well, right? So I think there are several such examples, but I think yes, that's the reason why we are really interested in learning from what we are seeing here. So, anyways, let's get started with this. Essentially, today we are looking at how we have, as Indians, grossly modernized the air defense and attack systems, and how it was successfully um, put at display in during the Operation Sindhur, and what we can learn from it. So, uh, let me get started. And the backdrop to this is pre 2020s, really the 80s, 90s, 2010s, where uh, we had limitations in our air-to-air combat. If you look at even the Balakot example, uh, the Pakistanis, they did have F-16s with long-range missiles, and our air defense, systems would struggle to respond. They were fragmented, and we of course saw what we saw during 2019, even as we succeeded in the operation itself, but we did come to know of the shortcomings at our end as well. And now cut to 2025, you have hundreds of drones and missiles attacking, intercepting, being intercepted, hundreds of drones and missiles attacking the enemy as well, without any aircrafts actually going from one to the other. So it's really interesting of how this transformation has happened, and therefore every Indian should know about it. So behind the scenes and see where we were before this kind of transformation.
Yeah. See, earlier days, 2 decades back, anti-aircraft gun meant that it was manually operated. Maybe it was motorized or powered for movement. Maybe loading of rounds was automated, and possibly firing was also automated. But the main thing, that is aiming was manually done, or at the most it was power assisted. Okay, but each gun was an individual entity, and it was standalone, and its efficacy dependent on the skill of the person who was behind. And that was the scenario in 70s and 80s. After that, going further, the anti-aircraft guns started sporting radars individually. So the gun carriage also had a radar of its own, and it could individually track the projectiles, and it could aim automatically, and it could fire. So this was an automation, but it was kind of standalone automation. One gun was still a standalone entity, in the
Hmm.
sense that it did not collaborate with others. It was more or less standalone. Okay, so that was that. Of course, manually operated guns, and this one, of course, we always had some command coming to the person who was behind. So I would not say that there was no communication possibility, but it was not done through technology. It was through some other devious means. Okay, so this was the next technology, which was, but the radar was hard coupled. That is, sensing of projectile was hard coupled with the aiming and firing unit. Okay, so that was the next level of change that happened. Next slide, please. Yeah. And then, of course, the the bombs which were fired, the arms which were fired, also became sophisticated and adaptive and automated in a way. Earlier, of course, like bullets, people used to fire dead ammunition, which will just go and hit like a stone. Okay, but soon after, we had ammunition which would explode there after hitting, and it had some kind of time fuse. Either if it hits first, it will hit and explode. Otherwise, with the time fuse, it will explode, so that it doesn't fall and explode on the land, because the land belongs to you. So maybe it will fall on some city and explode there. So that should not happen. So there was always a fuse which will make it blow up into pieces, smaller pieces, which would do lesser damage when they drop. Okay, so that was the next technology. Then came, of course, the heat seeking missiles kind of a thing, something which was, of course, relatively crude, but it could sense the temperature, the elevated temperature of the engine of aircraft, and it could track that. And but there were, of course, serious limitations in that also. Then came something which could be sidewinding, which could chase the target, which could autonomously aim and change its trajectory course. Of course, such ammunition will always have slightly bigger caliber, because of stuff which is there, intelligent stuff that is going to be there in that. Okay, so that is the latest generation ammunition which is intelligent, which can track target, and which will make sure that it will hit. Okay, adaptively,
Hmm.
irrespective of what the projectile does to escape. Okay, so that is the development on ammunition side. So there are developments on sensing system, there are developments on aiming system, there are developments on the arms themselves. Okay, or
And
the ammunition itself.
even within
Yes.
this, the distance that these could cover, that's also been a major addition to the capability of these to these
No, the specs
missiles and
of all
weapons.
the entities have been enhanced considerably, in the
Yeah.
terms of the speed of projectile that it can detect. If it is suppose flying at very high speed, uh,
Hmm.
maybe supersonic speed, even those should be detected. and right from small drone which could be made of all plastic parts to something which
Yep.
is as big as airplane or missile, big missile. Okay, everything should be detected irrespective of its height, irrespective of its velocity, and irrespective of the tricks which it does to escape detection. Okay,
Hmm.
so detection has become that much more intelligent, that much more adaptive, that much more agile, and also the range of ammunition fired. Of course, the range of guns has been enhanced, the range of missile has been enhanced, the firepower has been enhanced, the sum of the amount of explosive that it will carry, etc. And there are another kind of things which have happened, like there are projectiles fired which fragment and they burst into a shower of tiny projectiles, so that
Hmm.
as not to miss the target, something or the other will hit. Okay, so that's another kind of development which one sees in these armaments. Okay.
So isn't it not so it's not just the electronics, it's the material science, it is also the mechanics of it. A lot of it has seen individual innovations and all of it has come together for this kind of development, right? uh, the weight of the weapons and the ammunitions versus the distance that they can travel, versus the fuel that they'll consume, versus the velocity at which they would hit. A lot of it has to be balanced to give the real strategic advantage that each of these can.
Sure. But there have been developments on all these quarters. I mean,
Yeah.
all these attributes we see a lot of improvement. Okay, in last 20 years.
Yep.
Okay. Now, earlier, of course, there was an era when the person who's aiming with the gun, he had to fire live ammunition projectiles approximately towards the approaching intruder, and the features of like sidewinding algorithm, etc., could take over its propulsion and hit the intruder, filling which, of course, it will explode, as I said before, when it times out. And but there were limitations of covering intruders which moved faster or at very low altitude or at very high altitude, and there was higher dependent on human skill, judgment, training. And surgical strike which we did in 2019, of course, involved crossing of our troops into enemy territory with associated risk of collateral damage and uh, casualties on our side as well. Okay, so there was a risk to equipment, there was a risk to personnel. Now all that was the attribute of those times. Those were the features of the warfare in those times. But this time we see that nobody had to intrude, nobody had to cross the boundary, international boundary, or even POK boundary.
Hmm.
So everything could be done remotely, everything could be done unmanned. So that is definitely a very big game changer that we see this time.
Yep, and that brings us to the next segment in this, which is what went behind this operation, and really the technologies that were uh, behind the Operation Sindhur. So let's move on to that.
Now, earlier in previous slide, we have seen that the guns were standalone guns, anti-aircraft guns, and firing stations were more or less standalone. They were hard coupled to a particular radar, a particular sensing station, and then they worked as a local system. Right? But in this Operation Sindhur, we have seen flexible and adaptable integration of multiple radars and multiple firing and aiming systems and multiple kind of ammunitions all put together. So it was a kind of a grand integration. Okay, the kind of grand integration industry is trying to do through Industry 4, Industry 5, and such movements. This kind of thing was actually demonstrated. So if somebody asks me what is the evidence of something like Industry 4 or digital warfare uh, in India, yes, Operation Sindhur is definitely an example that can be cited, and it befits all the norms of these kind of digitalization movements. Okay, so AI guided target seeking projectiles They formed comprehensive multi-level, multi-distance defense system. Of course, multi-level systems had overlapping ranges and all, and
Hmm.
much higher level of precision in hitting stationary or moving targets. And in sensing, talking of sensing, there was a discrimination. They could discriminate between the drones which carried bombs and drones which did not carry bombs. And there was a clear cut sensibility and sensitivity that we could discriminate what was important to be fired and with what kind of ammunition was best to fire that one. And that could be adaptively configured as a system to address any intruder which is hostile, potentially hostile. We could adaptively face it in best possible way, in most economical possible way, and in most environment friendly way, because we don't see so many of shells bursting and lying here and there and environment getting polluted. There is no such report that ppm level has shot up in border areas. I mean, I have not seen such report. I have not come across. Okay, so I'm sure this time the warfare was much more environment friendly, like our production is environment friendly, like all that we try to do is becoming much more green and environment friendly. So that green initiative now extends to defense as well. Okay.
I think one of the ministers, I think it was the defense minister from the Pakistan side, he had given a comment which was pretty much laughed upon in India, right? When he said that we did not fire our air defense systems on the drones so that they don't reveal their own positions. Um, so that was something that was really interesting to me because these drones, when they enter the and I think there's another news which has come up today, which is pretty much there, where that India had also created a dummy aircraft just to pose as an aircraft, um, confuse the air defense systems on the other side, and then uh, by getting fired upon, identify the locations of these air defense systems where they are located within Pakistan, so that the next day when the drones were sent in, they could actually uh, uh, neutralize some of those systems as well, and pretty much make the further operations also much simpler for India.
Okay, as far as Indian side is concerned, I have seen pictures that most of these anti-aircraft firing systems are mounted on truck and those are mobile.
Hmm.
So it is very, even if somebody tracks it down from where it is coming one day, next day it may come from a different location.
Yeah.
So it keeps changing. So that surprise element and where from you fire, that is entirely in your control and it can be used to a big advantage. Okay.
Yeah. Yeah. Mobile. I wonder why they weren't mobile from the other end, but yeah, that's pretty much interesting. um, and possibly they were not even integrated, right? Like the integrations that we've had at our end, I don't think, because they've been buying out systems from different countries. Because one of the papers that I was researching was, when India displayed this kind of an integration, why have others not been able to? Why has probably NATO not been able to display that kind of an integrated capability, uh, while they have so much more, money to do that? And I think one of the key reasons was, from a governance point of view, every country has a different kind of a protocol that their weapons and ammunitions operate on, and they don't want to give out that to anyone else, and therefore there is a limited ability to integrate with other systems, and therefore a limited ability to actually even respond to a threat.
The problems are similar in industry also. We have some legacy machines, we have some machines from different geography, some machines from another geography with different standards, with different commands, and they are not really compatible. There are serious issues of interoperability. Okay,
Hmm.
so interoperability is a very, very big and difficult subject to deal with. Now, what industry has done, and I'm sure something like that would have been done here as well, is to not integrate it through the controller of the weapon. That is, radar controller is a separate entity, gun controller is a separate entity, Maybe we have put some kind of HMI boxes like what we do in machine tools to do industry 4, so that we integrate the machines which speak different languages through a common thread.
Hmm.
Okay, and those HMIs and those things which could communicate with the protocol that we have standardized upon in India can give us a very big leverage and advantage of being able to do it. Now, if somebody is not doing integration himself, it is very difficult. If you have all assorted equipment and weapons, it is very difficult to find a common standard of communication and common frequency of transmission, etc., so that they will be ever be able to integrate as effectively as we could do it.
Yeah.
Yeah.
Yeah. Uh,
One thing which
I'll.
reminds
Yeah.
me of this time is
Hmm.
talking of Indian mindset. We
Hmm.
Indian, particularly the technocrats, I am qualified to talk about technocrats. We are very good at building a house, though we may be relatively poor at building a brick. Okay.
Hmm.
So we are good system integrators. That is our skill set. We are good software integrators. We are good software IT people. Okay. So that is our inherent advantage over others as Indians. And that is what we have played to the hilt in this case. And that is what has made all the difference. Otherwise, weapons are weapons are weapons, radars are radars are radars, missiles are missiles are missiles. It is the integration of them, flexible integration, which has worked in our advantage.
No, and I think this is a gap which has been identified even earlier. So let me just put this possibly on stage, right? So what I was saying that there is a paper, and this is back in 2021 by Colonel Daniel Swanson. So he specifically, like you mentioned, the word interoperability, he does cite that even if you look at the abstract, he does cite as interoperability as one of the key challenges within the NATO alliance also, and the reason why they are not able to create that kind of a integrated system. And the reason why between Ukraine and Russia, even with all the might that the entire NATO is ready to put behind Ukraine, they still don't have an impervious air defense system. So I think we'll put this link in the description after the podcast is over, so anyone can go through it later. But I just wanted to put this out that this is something that a lot of countries, bigger countries, richer countries, have been struggling with for a long time, and that is why it is such a big, capability addition that India has done at such a low cost. Yeah, let's move on to the next.
This is a much publicized, of course, picture showing the long range, medium range, short range defense system that we have had. So I think we cannot elaborate too much. We would have read it already. Now, technologies which are demonstrated in Operation Sindhur is the to track the intruders ranging from swarm of small drones, cluster of small drones, right up to fastest fighter bomber aircraft, as well as missiles. And then having intelligence in our equipment to shoot the intruder so that hopefully its fragment drops at a safer place. We have not heard of any stories where the fragments of projectiles have dropped on some city or on some household or somewhere where the damage could be harming. Okay, they have fallen in some fields or jungles or mountains or somewhere. Okay, obviously there is extensive use of AI powered, remotely driven, or target logged, satellite guided, possibly satellite guided. Now I hear that at least 10 satellites were used in this exercise. Okay, so, and of course autonomous drones and missiles, not to speak of course Akash system, which is the backbone of defense which form, and all these of course names, S-400, Barakat, etc. You would have heard a lot, so we'll not spend too much time on that one. Okay, next please. Okay, now what is the outcome of these technologies? That there is no need for personnel or aircraft to cross into army territory for attacking. That is one big advantage. Missiles with a range from 250 kilometer up to 800 kilometer, they have allowed Indian Air Force aircraft to launch precision strikes on target deep inside enemy territory. We have attacked them all over while remaining
Mm-hmm.
within Indian airspace or near the border. Okay. Standoff munitions that can be released from aircraft well outside hostile airspace, and then they glide or guide themselves to the target using GPS, using laser, or using electro-optical guidance. Okay. Uh, some of them could be, of course, guided through monitor manually, like those drones were, and probably for that reason it made a difference if you had a blackout or you did not have a blackout, because drone has a camera which will not be able to see if it is not GPS driven. If it is GPS driven, then blackout doesn't make any sense. I mean, now is the
Yeah.
era of Google Maps and all. Why do you need what? How does blackout matter? So blackout matters for two reasons. Obviously, one is, of course, not all devices are running off satellite-driven GPS, etc. Some of them have their own cameras, and somebody is driving them through camera. So for those devices, yes, blackout is still relevant. Another thing is that for our armed forces to be able to locate those drones and those missiles and those projectiles through their trailblaze or whatever lights they have. I mean, in videos you do see a lot of lights, and thereby they could be located. Either, of course, we may have fired some tracers to make them visible. That apart, but then uh, yes, that is something that optically they have to be tracked. They have been tracked, and real-time satellite, drone, and airborne surveillance. They have provided precise targeting data, enabling standoff weapon to be used effectively without crossing the border. And we all have heard about Rafale and Sukhoi 30, etc. Now, these platforms are obviously equipped to carry and launch long-range standoff weapons, and they are obviously integrated with advanced avionics and targeting systems to maximize the strike accuracy and survivability of these aircraft.
Yeah.
Yes,
And
please.
with the long range weapons, which have a lot of weight as well, these kind of platforms help so that they are able to fire them without entering uh, the other territory as well.
Another aspect which is glaring in this Operation Sindhur is that they have not been able to track our satellites. They have not been able to intercept our missiles. Okay, so obviously a lot of jamming techniques must have been used. Okay, these are just the theoretical kind of jamming techniques: spot jamming, barrage jamming, sweep jamming, where you sweep through various frequencies, and at whatever frequency they are operating their radars, etc., you can deceive it, you can block it. And of course, deceptive jamming, where it gives some ghost images on their equipment to deceive them. So there are, of course, various jamming, intelligent jamming techniques, I would say, which have been used. And as I said earlier, this is war of wits. So who outdoes whom is all that matters in this electronics warfare. So who can deceive whom and what clever tricks he brings out and puts it as a surprise value. Yeah. So spot jamming, barrage jamming, sweep jamming, deceptive jamming. Uh, of course, there is something which I came across that is called as a drone killer gun. Now that gun doesn't fire any projectile; it beams a strong radio signal to make the drone go haywire. It loses control and then it drops some, okay, without firing. Yeah. So there are some such equipment nowadays, of course, available. But then, of course, they are fired like a regular gun. Somebody has to aim and shoot, because it will not send the radio waves everywhere. It is directed as a beam. Okay. So again, it is somewhat like a laser gun, if you please. Yeah. Where you have to aim and shoot. Yeah. So these are the jamming prowess that we have displayed, obviously, this time. And we need not know, and we don't know really what was used out of this, but surely it had a surprise value for the enemy. Whatever were used,
What's
they
really
did
interesting
hit the
to
target.
What's really interesting is to do that, you would need to understand what is the frequency being used on the other side. How how that was gauged. I mean, there could be different ways,
No, that
but
probably
I
can
think
be
that's just.
detected because any electromagnetic waves emitted, I mean,
Hmm.
after a while you can find out what is the frequency from where it is coming, etc.
Hmm, hmm, hmm.
We have multiple sensors, multi-point sensors. You can apply some stereo signs and find out and do some ranging and find out from where it is coming, what frequency is coming. All that is also possible nowadays, which is not so difficult.
I know this
But
will
then
go into speculation, but do you think it was not uh, on ground intel gathering, people finding out this, or or do you think
may
it
have
was
been that as well, but
it was done
I would
using
not say
technology
so.
just across the border? Yeah.
No, but one speculation I will hazard that probably why they did not have mobile firing stations and mobile detection stations, and they had maybe grounded things because it is a terrorist infested state, and there is every possibility that those trucks can be hijacked by PLA or by somebody and misused against the
Yeah.
state. So probably for that reason they prefer to have everything on ground, heavily guarded and all. But then it makes them rigid and vulnerable. They become like sitting ducks literally.
Right. Cool. Um, so now that we have looked at the technology, now let's look at what went behind creating that technology. And there were obviously many initiatives and people from within the government or the defense ministry or even DRDO and such institutions would be better placed to give more details about all of this. But at a high level, what it definitely looks like, there was a big drive to firstly modernize the existing inventory that we had, right? So the L-70s that we saw earlier, the government made a uh, wise decision um, to upgrade what we have from being uh, a radarless dumb system which is manually held and managed to something which can be automated, then added the radar to it, and then that integrated with the overall integrated communication systems. So I think the the cornerstone of this specific exercise would have been to modernize what we really have versus spending big on some things which will be ultimately too expensive to fire down a drone which may or may not carry munitions, right? So I think that is one of the key things that came out from this modernization drive to me. And I think same goes with the radars as well. The indigenization of the radars like Rajendra and BSR, etc., that has added to our ability to add these radars cost effectively to a large number of equipment that we have. So, and I think that's what being someone who's been working in the industry 4.0 kind of a domain, buying a new machine to just generate data, to just integrate and control, that becomes too expensive an affair, and therefore most of the organizations don't do it. But there are challenges with refurbishing and retrofitting, but I think that's where you need to start off cost effectively and then go beyond that. Would you
In one line, I can summarize. See,
yeah,
you don't use missile to kill mosquitoes.
yeah.
So you have to use appropriate technology, appropriate arms, appropriate. There is an economic side also attached for a long drawn war. Like you can't afford to spend too much on dropping a drone which has a paltry cost, is a very low value item, right? So
Possibly the reason the defense minister from Pakistan also said that we refrained from shooting down
yeah, yeah, yeah,
drones. Yeah.
sure.
And then, of course, these are the different things that we've
We have
built,
seen all
bought,
these pictures a lot
added.
in the
We've
media,
seen,
but
yeah,
okay.
many more of those. So we will not go through this. But essentially, what the government and the policy makers brought to it, right? So Atmanirbhar Bharat, we heard make in India. We heard about 10, 11 years back. Then we heard Atmanirbhar. during the COVID times. All of it seemed to us like jargons. There's a lot of jargon there within these policies even till today. The ease of doing business is still not where it should be. There are a lot of problems, and I have made a lot of videos around that. And there are a lot of things that we've done, which we've also highlighted. But this comes across as something which has worked through Atmanirbhar Bharat, where these policies have pushed for self-reliance, indigenization of manufacturing, and innovation. The initiatives like IDEX have created space for startups which otherwise would not find funding from VCs or private investors. They would not find people backing them up to develop a drone or a drone defense system. But now there are startups which are working in this space. There are startups who are working on the next generation of 5G and communication, sat communications, etc. uh, Plus what we see is a very good integration with the public private, where you have companies like Tata and Adani working very closely with the government, DRDOs, BELs, to at scale deliver what the armed forces really need. And finally, the procurement processes have, since Mr. Parekar's time, have kind of become better, have been more streamlined, and that has added to the ability to generate this kind of inventory, which we can bank upon, but someone like Pakistan cannot. Finally, I think, while these are the things that went behind, what has worked, what hasn't, but now as engineers, I would be really interested to know what would the way forward really look like, right? So, um, where are some
Well,
of the ideas? Yeah.
way forward, we have to spring a surprise yet again, because whatever we have done now would be expected next time from us. So we have to do again something, we have to outdo ourselves and set a new standard and do something which has the similar kind of surprise value for enemy. We can't be repeating ourselves in the same way. Next time it will not be effective. This time it was because of surprise value. Next time we are sure enemy would be prepared for that. That's okay. It's not something if we use the same thing, it will be equally successful next time in time to come. No. So what I can imagine are some changes that instead of using ammunition, if laser weapons are used, for example, where no projectile gets consumed, the ammunition does not get consumed. So you don't have supply chain issue, you don't have issues of running out of ammunition and those kind of things. You are using only electricity, and you can fire, and you can extend the length of ammunition, because the laser beam you can go on traversing until it hits. Okay.
Hmm.
And there is no problem of debris of used or spent or fired projectile dropping somewhere causing damage and concern. The fragments of your own ammunition could be disintegrating and falling on somebody's head. So that is always a hazard. Okay. The other technology that we can anticipate is probably surveillance, detection, and navigation, controlled through satellite to a higher degree, where the enemy cannot destroy your command center on ground, because satellite destroying capability nobody has, frankly. Okay. So that is something which, even if it is tracked, nothing can be done about it. And there are multiple satellites that we have anyway. So that is a different level of warfare. Okay. Because terrorists or some spies can probably bomb your resources which are located on ground sometime. Okay. Or somebody can fire a missile sometime when you are less guarded, and then there could be damage. Okay. Or there could be some thing done like electricity is cut off, etc. So there is a temporary blackout and something, and within that time somebody does something. Also, one scope that I see is going further is in the videos that came across where the projectiles were being hit, targeted. We saw a lot of cluster of fired projectiles chasing one target. Going further, it should be optimized heavily. One projectile means one target should be hit. Every ammunition should hit one target. Why it should miss? Now that you have AI powered algorithms, etc., what is the need for redundancy? Need for redundancy was there when you were not sure that it will hit the target. But once you are sure that every projectile will hit the target, you can optimize. You can economize so that your war becomes much more affordable, economical, environment friendly, consumes less resources. Okay. And so that is something which we can look forward to.
Hmm.
And another aspect is this time we saw drones and airplanes are seen as moving lights through their trailways. Some technology to black out the flying drones and the flying missiles and the aircraft so that they do not become visible to the naked eye optically. Okay. So blackouts should become a thing of past for modern warfare. Okay. Blackout was okay in First World War, Second World War times, but now with these advanced technologies, where is the room for blackout and what difference should it make? Okay. And there is an evidence that Indians have hit their Pakistani targets at night,
Hmm.
possibly when there was blackout, but it did not prevent us from hitting where we wanted to hit. Okay.
Hmm.
And last but not the least is we have to make our own equipment jamming proof. Now that's a tall order. So there are two things which I would say here. One is that we already have multi-level, multi-tier sensing systems which have overlapping ranges of radars, etc. We should also have multi-technology sensing. Like not everything is based on electromagnetic waves where it can be jammed. Something is optical, something is sonar, something is so use different combination of different technologies because nobody can possibly jam all the technologies at a time. Okay. Another thing is that okay, if you are constant to use electromagnetics, use electromagnetics by all means, but then don't use a particular frequency. You keep changing very frequently, and that should not follow any pattern. It's like you have an algorithm to generate random numbers. You generate random number and that frequency you use. Okay. So that nobody can find any method in your madness. Okay. And you are
Hmm.
still able to get away. Nobody is able to block you out. Nobody is able to black out your senses. So that is another aspect. Of course, since our sensing is also through satellites, which is much more difficult to jam. Okay. But multi technology is one aspect, flexibility is another aspect. Keep changing, keep things mobile, and keep the frequencies also mobile
Hmm.
dynamically. Okay. So it is war of wits, who outwits whom, end of the day. Okay.
Yep, I
So
agree. It
something
does, and
like
I
that
think
I would imagine could happen in the next such episode.
I think
Till then, of
yes, I
course,
think
let us keep
this
our fingers
warrants.
crossed and let us keep our spirits high and let's have trust on our scientific and engineer community. I'm sure they will do a damn good job next time also.
Yeah, yeah, I agree. I think this does warrant this specific conversation on what are the various ideas for the way forward. I think this does warrant a further more if not detailed, at least a little more elaborate discussion on what each of these could be, and if there is something similar being done in some other domain, we could probably have a look at that as well. So I think we could plan to have another conversation on some of these ideas, how they could be taken up, where they are presently being used somewhere else, and that could be an interesting, next step on this specific podcast. But as we hit this 50-minute mark, I think that's a wrap on our time for this today. I hope you found this conversation useful. We have been we've been looking at the news like you, and we've been analyzing the reports that have been coming through. But our interest really is in the engineering and the industrialization domain of this, and we'll try and bring more updates on this as we move forward. And we'll also uh, add what ideas and what innovations could come through this, which could be of use for civilian applications as well, as we have some further conversations on this thread. So thanks a lot for watching. Do like, share,
Just
and
to conclude,
subscribe.
I would like to add
Yeah,
something
no problem.
that talking conceptually, of course, businesses do have moving targets just as defense has.
Mm,
Okay. And they also have to be sensed, the damages have to be sensed, the upheavals have to be sensed, and coordination, integration, all those concepts are still required. Okay. Okay, here you are not killing the enemy, but then you are uh, gunning for performance. Okay.
yeah,
So how you outdo your competition in terms of performance, that is the main concern in business. So some of the concepts can be, of course, borrowed at philosophical level, at concept level, and you can implement it through management also. It need not be technology only. Always. Okay. So
hmm,
so there is a lot to learn. There is a lot which we can borrow from this one and do it in other domains as well. And that's the idea of progressing and growing together, learning from each other in different domains. Okay,
absolutely.
all the best.
Uh,
Bye bye. I hope you have enjoyed the talk.
Bye bye. Do like, share, and subscribe. See you. Bye.